I don't know. I don't know. If Bitcoin becomes sound digital money, and that's really a success, then it's going to go higher.
Bonsoir.
That's it.
Goedenavond.
But there's still other challenges.
My name is Sebastien Couture. I'm a technology evangelist at Stratum. And I'm very happy to be here at this meetup tonight. Because this place is actually kind of interesting. This area is sort of where I first started discovering Bitcoin and meeting interesting Bitcoin people back in, I guess, early 2014. I wasn't living in Paris at the time, but I was coming to Paris quite regularly, and I used to put up accounts right here, and used to work right across the street. And so, oh yes, we're talking about Bitcoin. I wasn't sure whether we were this one or the Ethereum one this morning. So yeah, this area is kind of means a lot to me in terms of my education around Bitcoin and such. And I've actually given a few talks across the street. It's my first time giving a talk here. So I've got a couple of hats in this space. I'm the co-founder and technology evangelist at Stratum, and we'll talk more about what Stratum does. And I'm also a podcaster. So I run a podcast called Epicenter. And Epicenter is one of the leading podcasts in the space. You can find our podcast at epicenter.tv, or iTunes, or YouTube, or SoundCloud, or pretty much anywhere where you can download podcasts. And we tend to interview people that are working on interesting projects, technologies in which we're interested in, and things that are changing the world. And I think we have a pretty diverse audience of different types of backgrounds, but really thoughtful and pragmatic people. So if you're one of those people, you can probably like the show. So what I'm going to talk to you about tonight is a project that Stratum has been working on for the last few months. And hopefully through this presentation, you'll get to better understand our core technology and how it applies to the enterprise. I won't be talking about Bitcoin very much. We'll be debate that and talk about whether or not Bitcoin is more important to Ethereum or any other platforms out there. So, over the last 40 years, we've seen a lot of push towards streamlining inter-business communications, inter-business processing. And there's been this push, mostly because of technology, but also because people are looking for more efficient ways to communicate. Notably, companies are working towards finding better ways to communicate. And although we've seen a lot of this push actually take place, we still rely an awful lot on trusted third parties. And trusted third parties, as you know, they introduce some complexities, they introduce costs and friction, and we've tried to eliminate them as much as we can. So companies collect data. I think we're all aware here that companies collect an awful lot of data. The companies are also meant to share some of that data, sometimes with their partners, with their clients, with competitors, and sometimes the regulator or auditors. And this is true in the insurance business, especially here in France. We'll get to see how. So we work very closely with insurance companies. Our investors are mostly insurance companies. We found that to be a market where there's a good level of maturity with regards to blockchain and what these companies are doing with this technology. So insurance companies collect a lot of data, and they're required to share that data with their partners, with regulators and auditors. And although a lot of that does happen through electronic platforms, APIs, so on and so forth, a lot of it also happens through Excel files and emails and other not so secure, not so modern means of exchanging information, such as fax, registered mail, sometimes even just regular letters. So what we do at Stratum is we can help companies in the hyper-connected economy, which is the economy in which we're in today, better collaborate with their partners, with their customers, with the regulator, And we invented, put together technologies that allow them to do that. So what we do is we help our clients build these industry-wide networks that will allow them to hopefully be more efficient, streamline their processes, in the long run, reduce costs. So we built a suite of tools, and the very core of what we built and what we sell to our clients is called proof of process technology. And proof of process technology leverages blockchain technology, it leverages cryptography, it leverages peer-to-peer networks, and these tools are meant and are designed to improve user experience for operations teams and enterprise, but not only that, also the customers in the long run, right? So a lot of these applications will end up being B2C, reduce costs, and reduce any type of friction that is introduced by just third parties today. And also, as you'll see here, simplify regulatory compliance procedures in certain types of very specific regulatory processes. Getting a sec. So what I'm going to talk to you about today is a project that we announced 2 weeks ago. You may have seen it in the media. We announced a project working with the French Federation of Insurance Companies, the FFA, and 14 leading insurance companies. And we worked with Deloitte as well to build a platform that will help streamline all of the procedures surrounding a new law, which you may have heard of, called Loi Hamon. The Loi Hamon is a set of regulations, but within Loi Hamon is a specific set of regulations that opens up the insurance market, essentially opens up competition in the insurance market in France. And as a policyholder, someone who has home insurance or auto insurance, you can now very easily switch insurance companies. So just as you do when you want to switch to phone providers, you can now do it with your insurance. And so if, say, you're insured with insurer A, if you want to change to insurer B, because they, for whatever reason, after 1 year, you can now contact insurer B and say, hey, insurer B, I'd like to be insured with you guys. And insurer A and insurer B will engage in a series of messages and make sure that your contract gets transferred. And all of that, all the administrative procedures there are no longer in your responsibility. It's up to the insurance companies to do that. It's really great. I mean, as a consumer, it's really great. Because the insurance companies will make sure that your contract gets canceled in time, that any interesting information or any specific information that needs to be transferred to the new insurer will happen as well, without you having to do anything, and that you have a new policy without constant coverage, which is important. And so the way that insurance companies do this, the only certified way that they can do this, because it's important for them to have certification. So if there's any type of dispute, you need to come back and say, you know, we did this, or they did this. And so you need that traceability, that authenticity of data, and the integrity of the data, which John mentioned in his presentation. You need to have that. And the only way that insurance companies have had to do this so far is the French Post's electronic registration service, believe it or not. So it is electronic, but it still sort of relies on antiquated ideas of how we should transfer information. And there's several setbacks, several drawbacks with this solution. The first is that there's no streamlined workflow automation with electronic registered mail. You're essentially just sending one message, someone's sending you another one, and there's no way to automate any of the business logic or the validation rules that should go into how the data is treated when being sent from one party to another. The second drawback is that there is, insurance companies are sort of left in the dark when it comes to their own data. They can't really see in real time in where they're situated in the process. And so, for instance, if we wanted to automate the action of a customer being able to see where he's at in his process, you can't do that without electronic registry. And the third is that it's quite expensive. It costs several euros per message sent. And that doesn't include any of the overhead costs, manual entry, data reconciliation, all this sort of stuff. So insurance companies are highly incentivized to try to find a better solution. So the process looks like this. This is WAP right here, okay, as described in regulation. And with or without a blockchain, this is what it looks like. And so, you can look at this online. But basically, there's a series of messages that we built. And what we built is we built a platform that will allow French insurance companies to engage in this process in a way that happens in real time, where we have authenticity of the data, where we have timestamp, which we know, where we have the notarization aspect. So essentially we know who did what, what time, what order, all that, for the final question, which is for what reason, and that is to transfer an insurance contract. So I'd like to show you a demo. So for simplicity, I've made a little video. Also avoid any surprises. Server's not working. Okay. So this is an insurance company's customer mobility portal. It's from this platform that insurance companies are going to manage mobility requests. Now let's imagine that Zoe. I think there's a script for this, right? So right now we're logged in as the Cedar entrance center, right? So this is someone at Cedar looking at this interface. Now let's say that Zoe contacts Cedar's call center and says, "Hey, I want to be insured with you guys. I want to open a new home insurance policy." So a Cedar employee would fill in her personal information, and so Zoe is currently insured at Azure, which is a competing insurance company. So we'll make sure to signal that during the process, and we'll enter any other information she has, contract number, when the contract should be canceled. In this case, there's other information. She's got an ongoing flood point, so her kitchen was flooded. And that's actually still going on right now with Azure. So we'll make a note of that as well on the platform. So once we've verified everything is correct, we can go ahead and submit. And that will get submitted as an initial step in this process. So what we can see, once we've submitted it, is that the case is currently it's pending processing by Azure. Azure Insurance has the process and they're meant to act on it. And so what proof of process provides in the back end, so what we see is the initial step in this process. And what proof of process provides is the tools that allows internal auditors, potentially even external auditors, to look at this data and audit it. Now, the Cedar employee, right, the customer service representative can do this, but an auditor or sort of auditing engineer will look at this and be able to audit the data. So here we have the fingerprint of the data, along with all of the data, and the proof that it was in fact added to the consortium blockchain that sits behind this platform. Now looking at the sent request, we can see that the request is currently pending processing by Azure. So now we're going to switch. We're going to go over to Azure Insurance. So notice that we've completely switched change platforms. That's because every insurance company is hosting their own interface and their own node, which they're grabbing data from. And so in this case, we're using a unified web app. Everybody's got the same app. But when this goes to production, we're not going to expect insurance companies to use some other interface. No, they're going to use whatever ERP system, like a CRM or SAP. They're going to use their existing IT systems. This will simply sit underneath it and connect to that system using the API. And retrieve proofs, store them in the blockchain, and send data back to that platform as a single source of truth. It's going again. We'll see that going to the incoming requests. Okay, so now we go to the incoming request list. We can see Zoe's claim or case. It's coming from Cedar.
And we can see that there's an initial step in that process, and we can verify information. Now, in this case, because she's got an ongoing floodplain, unfortunately, it doesn't comply with the rules at Azure, so we have to reject it. So we'll give a reason for that. So in this case, your ongoing claim must be closed. We'll send that, and so we'll get the third step in the process. And so we'll see that this is the rejection step. And this information also gets added in the blockchain, along with data that's been validated for that specific step. And so once again, an auditor can look at this information, see the insured information, and now we can see that the case is coming back to CEDAR for processing. So in this case, it's a very simple two-step process, right? So we could go back here, and then we see that the case has been rejected by Azure. And so any internal process is necessary here would have to be active on. Now, I'd like to show you what happens when we look at this from a third insurer's point of view. Oh, before I do that. Now, all this information here that you see is not being pulled from a database. It's actually coming from the underlying blockchain. And I'll talk a bit more about the technology in a bit. But the data is coming directly from the blockchain. So as someone looking at this, we know that it's coming from the single source of truth that has been validated by the consortium of members. I'd like to show you what happens when we look at this from the third insurance company's point of view, Marigold. Now, looking at the center incoming request list, we won't see Zoe's case anywhere. And that's because the data is encrypted in such a way that only the two insurance companies involved in the claim, in the case, can see that information. Now, we'll be able to audit the blockchain, look at the block explorer, and see the transaction itself with the encrypted data. But the keys are encrypted in such a way that we don't even know who sent what to who. Now, an auditor could look at this. We'll talk a bit more about the technical aspects of this in a moment, but an auditor could look at this and validate that the data is correct, because the validation rules are actually within the smart contract application that is receiving the data. So the validation rules are validated by the blockchain. However, a user won't be able to see the information. So that the customer's information is encrypted. It can only be encrypted by the two parties that are involved. So this project was an experimental solution that we built with the FFN and Deloitte. We'll be working closely with them to hopefully bring this into production sometime next year. And I'd like to talk to you about what's under the hood. What makes this work? So what makes this work is proof of process. And proof of process, I'll show you the link to the website afterwards. So proof of process is a protocol that we've developed that allows you to prove who did what at what time and what for what reason. And it describes how you can use blockchain technology to do this. Cryptography, peer-to-peer networks. And so we've built a stack that is basically the implementation of proof of process. And in this stack we call the Indigo framework. So proof of process is the protocol itself, and we've built an implementation called Indigo, and other implementations can exist. In fact, we're working on different implementations. But the implementation that we've developed utilizes a blockchain stack called Tendermint. Now, who's heard of Tendermint here? Okay, so you'll know that Tendermint is a project that was built, it started in 2014 by a guy named Jake Wan, and now has a team of about 30 people. And so Tendermint, that platform will be used to power what hopefully will be sort of the internet, the blockchain of blockchains, which is the Cosmos network, which hopefully will be in production in a few months. But the core of Tendermint is a system that allows an application to be replicated on different machines. So what Tendermint did is it took sort of the principles of blockchain and said, okay, well, we're going to build a platform from the ground up. And we're going to build it with good programming best practices. So we're going to separate all the pieces. So you have the consensus, you'll have the ledger, and you'll have the application logic. I mean, that's what a blockchain is essentially, right? You have a consensus mechanism, you have a ledger that's shared by peer-to-peer networks, and you have some sort of logic. Bitcoin does this, Ethereum does the same thing. And the way that Tendermint implements it is it says, okay, we're going to have a consensus algorithm, PDFT consensus, Byzantine fault tolerant consensus. that has certain properties, a shared ledger over a peer-to-peer network, and the application logic you can write in whatever language you want, right? So if you compare that to something like Ethereum, where you have a virtual machine that allows you to write your applications in Solidity or Viper, Tendermint says, you want to write your application in Java? Write your application in Java. You want to write your application in Go? Write your application in Go. And we'll provide you with the protocol for your application to talk to the consensus mechanism. And from that point on, any transaction, any data, any proofs that you send to the blockchain will be added to the distributed ledger, which is also part of Tendermint Core. And so what this means is you can build pretty flexible types of applications. And so just to talk a little bit about the consensus mechanism in Tendermint and the way that we've implemented it. So this project is in fact meant to be a consortium network. So a network of actors that know each other, that share keys, so there's no mining or any sort of thing of that nature. Consensus happens through voting. And so there's a mechanism that allows members to essentially have turns voting on what blocks get added to the blockchain. And where in a public blockchain we want to favor the availability of the network, right? We want the network to always be available because we want people to be able to make transactions. In this setting, we're going to favor we're going to prioritize something different. And that is we're going to prioritize consistency. If the network goes offline for a little while or for a few seconds because some connection got cut or something like that, that's not really an issue. And on top of that, since we're in an enterprise setting, the assumption is that we've got pretty good network connections and connectivity is pretty good. So availability is not so much an issue. However, it's very important for the data to be super consistent. And so that's what Tendermint offers as a consensus mechanism here, is we have consistency in the data, finality in a few seconds, right? So if you compare that to something like Bitcoin, where the use case is totally different, finality happens within, say, 30 minutes to an hour after you've had several blocks confirmed. In Tendermint, you'll have finality in a few seconds. And threshold, the security threshold is about a third. So you need to have a third of the participants be malicious in order to create false blocks. And so once again, in a consortium setting, where we're talking about companies that have interest in having a single source of truth, we're pretty certain that the probability of having a third of the participants be malicious is quite low. So for this use case, this technology was actually quite useful and really corresponded to the requirements. So Tendermint is at the very bottom. Okay, so I don't know if you can see here. So there's actually a blog post that we posted on our blog, blog.strive.com, where you can get all this, right, all the details. So Tendermint is at the very bottom. Well, let's start from the top. You know what? So the user interface is what you saw earlier. Okay, so this is your web application. Zoom in actually. Aha. Right on. Okay. So at the very top, we've got the application. So this is the web app that we saw earlier. It could be SAP, it could be any type of CRM system that a bank or insurance company is using. And we've got the agent UI. And so the agent UI is the auditing tools that we also showed you. So those will connect, will be considered components of the front-end client-facing application. And then that communicates with the Indigo framework. And the Indigo framework constitutes a piece of software that every consortium member has installed in their infrastructure. So we don't hold any of the data, we don't want to touch the data. Our clients are masters of their data, and they're proprietors of their data, as well as their infrastructure. So the agent, the proof of process agent, is essentially where you create the APIs that will connect to your front-end application. So in this case, for this application, you've got 4 different nodes running. They're all the same. They all have the same. They're all the same web interface. But if one's using SAP, and the one's using AS400, and the other one's using another infrastructure, those APIs are going to be different for everyone. They're slightly different. So the proof of process agent talks to what we've built as Tendermint proof of of process. And essentially, it's sort of a smart contract application. So this is the application logic that I talked about earlier. And that application logic is written in this case, in Go. It could be written in whatever you want. And this specific application is what we call a tenement pop. And it just gets proofs, validates them according to predefined business logic based on the specific process, and sends them via what we call the ABCI protocol. Not to get into technical aspects, but the ABCI is basically that socket protocol that allows Tendermint to talk to the app. And so once that information has been validated, or sort of been processed and validated in a way that it can be sent to the blockchain, it gets sent to Tendermint Core, which has the consensus algorithm and the ledger storage. And this is part of the broader network. Okay. So, right, so every node here basically has this infrastructure installed on their systems. This remains the same, but the very top layers would be different. You know, we'd have some customization that would need to take place there. I also forgot to mention there's application storage at this level, and this is simply so that the front-end applications can access the data. It's sort of caching, but it's meant for the front-end applications to access the data much more quickly. So there you go. Those are the different layers. So essentially, right, when a client application makes a request, it sends that request through the agent. The agent sends that data to the application, and this being part of Tendermint is replicated, so every participant has the same application. So we can prove this, and you can have trust that your data is being processed in accordance to how this process was meant to be executed. It could be also signed off by a regulator. Right? An auditor could look at this code and say to the regulator, stamp of approval, this process is regulatory compliant. And it sends that to Tendermint Core, gets the consensus, and then sends the data back to the application storage as proof that it was in fact validated by the network. So this is what we built. And so just to sort of summarize, what we've demonstrated is an application that allows multiple participants in a shared process to have faith in a single source of truth. And applications for this go well beyond insurance. And we work very closely with insurance companies, but applications for this can go well beyond insurance, financial markets, energy, supply chain management. And what we think that there's an opportunity here to create industry-level platforms. And in these industry-level platforms, we have an opportunity for new types of collaborative applications to emerge, trusted collaborative applications. So we're working closely with our partners and our investors who are also, in our investment round, CNP and BNP Cardiff have invested in strategies. So we're working very closely with them to build networks to manage internal and industry-level processes. So I know everybody wants to go drink some beer, so I'll just end on this. I think that this is about so much more than this technology. I think that at the very core, the value proposition of these types of systems, once we've identified the proper use cases, is about simplifying and automating and streamlining a lot of business processes that costs a lot of money and a lot of headaches to enterprise. And I think that one of the value propositions of that, when speaking to an insurance company, saying, okay, you, insurance company and insurance industry, spend X millions, hundreds of millions of dollars a year regulating, ensuring that these processes are executed in compliance with regulation. Take that, simplify it, streamline it, and take those hundreds of millions of dollars a year and put it towards what really matters, and that's creating meaningful relationships with your customers, getting to know your customers better. So, if you want to learn more, I invite you to check out a couple things. So, proof of process white paper, proofofprocess.org. It's not a very technical white paper. It's actually quite easy to read and quite fun to read. So, not too long. So, I invite you to read that. If you want to get started, if you want to spin your own Indigo node, you can download that at indigoframework.com. We've got all of the tutorials over there to get started. You can also join our Slack channel, slack.strong.com, and on Twitter, where else. And I'd be happy to answer the questions. Thank you. Yes.
A question, but first a comment about the piece of process.org. I read it, it's, like you said, short and easy to read, except the last part, which I think is too short, on zero knowledge proof.
Yes.
Maybe you want to improve that. And my question is about liability. So none of these is final, this is beta, this is POC, and proof of concept. And at some point it will become live. If something goes wrong, who's liable? Are you?
Okay, so the first question was ZKP. Thanks for pointing that out. So who knows here what ZKPs are? Zero knowledge proofs. Okay, so the zero knowledge proof, let's see if I can explain this correctly. Zero knowledge proofs are essentially a way to prove that a computation occurred without seeing the computation or the data. So I can prove to someone that I'm over a certain age without them having to see my birth date. So, a simple ZKP circuit would look basically at this information, verify the information is correct, and on the other end say yes or no. But you can't see the data, but you can trust the data because it's been signed by this thing that everybody agreed upon that this was the logic. And so there's software ZKP, and that's one of the things that I think you're mentioning. And there's also some hardware ZKPs, which are what we would call trusted execution environments. You may have heard of the HDX. And so I think that these technologies are so important for the enterprise space. And I think that a lot of the discussion around blockchain will start moving towards ZKP and SGX when they become very available. So that means right now you can just spin up an Amazon instance and get a server. Tomorrow you'll be able to spin up a trusted execution environment on a cloud server, and basically a lot of this consensus stuff becomes sort of obsolete, or at least it gets augmented by these trusted execution environments that are essentially signed by Intel or AMD. Not to get into so much more of that, but we have a research team, and a lot of their focus is on ZKPs. And so within the, so I didn't really talk about the enterprise stuff. So this is all open source. What we sell to customers, what we're going to be selling to customers, is all the enterprise tools to allow you to deploy your network, to manage your validation logic, the consensus around governance, and how to implement ZKP circuits within these types of applications. That's the Indigo enterprise stuff that we're researching at the moment and doing some good headway, I think. The second part of your question was about liability. That's a good question. I don't think we have all the answers to that yet. I think a lot of the industry doesn't have a lot of answers to that yet. With regards to specific liability within the applications themselves, industries can agree on what tools they use, and if, say for instance, a consortium of insurance companies agree contractually that this is the source of truth and this is where we see this with like, what do you call it? In all sorts of regulated industries, they'll go to arbitration before going to the courts, right? So this is sort of a level above that, above arbitration. Let's look at the blockchain before we go to arbitration. Now, your question may be leaning towards like liability if the software breaks down. Is that your question? Like, who's liable if the software breaks?
For instance, you guarantee that only the two insurance companies that are involved have access to the data. Let's say that there is a bug and everyone has access to the data.
Yeah. I don't think I have the answer to that question right now. Yeah, but there are things that we think about a lot, and so we have, people have this. Yeah. But I don't have the answer right now.
Usually the answer is in the end user license agreement, which is saying this software does nothing.
That might be one of the answers. Also depends on what we actually sell. Like I said, so the open source stuff right now is sort of available, and we know what's compartmentalized in that. The enterprise software and the enterprise product that will be coming out in a year from now is still being built. And so part of that is end user license.
First of all, thank you for the presentation. You really built the cool stuff. My question is that, you said that the Indigo framework is open source.
Yes.
So can we build products on top of that?
You can.
You can build companies on top of that, right?
You can also build companies. Yeah, you could. I mean, if you would deploy it in a way that, I'm not sure what company you're looking to build on it,
Yeah.
but if you wanted to build some sort of company that leverages Indigo and you want to build a product out of that, yeah, sure you could. Cool. Yeah. We can talk later about that if you want.
All right. I guess maybe we've got time for one last question. Put their hands up. One last thing to mention. Thank you for your presentation, Sebastien. We're running out of space at SoftSpar. If you guys are interested in getting post-meetup drinks, so SoftSpar at 43 Rue Saint-Sauveur. I hope to see you guys there, and thank you all for attending our meetup. Thank you.